Enriched Air Nitrox. Before the early 1990s, few divers had heard of it. But today, its ability to extend your dive time makes it mainstream. In the early years, you used dive tables because there weren't many dive computers that could run Nitrox. No more. Today, virtually all dive computers run Enriched Air, and the diver using Enriched Air tables is the exception rather than the rule. That's what the PADI Enriched Air Diver course is all about. Certification as a PADI Enriched Air Diver means you're qualified to buy or rent enriched air dive gear, get enriched air fills, and to plan and make enriched air dives using a Nitrox-compatible dive computer. Maybe you've heard of enriched air Nitrox, but you're not sure exactly what it is. Basically, it's air like you're breathing now, but with a higher proportion of oxygen. Recall that air is roughly 21% oxygen and 79% nitrogen. Enriched air has more than 21% oxygen. How much more depends on the blend, as you'll see shortly. This isn't for more oxygen, but for less nitrogen. You'll hear it called different things. EANX or EAN for enriched air nitrox, or just nitrox or enriched air. It's all the same stuff. To name a specific blend, just add the oxygen percent. Call enriched air nitrox that's 36% oxygen, 64% nitrogen, EANX 36, nitrox 36, or enriched air 36. The benefit of enriched air is that it exposes you to less nitrogen during a dive. In your PADI Open Water Diver course, you learned that it's nitrogen absorption that sets your no decompression limits. Enriched air extends your allowable bottom time, eliminates the need to push the no decompression limits, and reduces your overall nitrogen load following multiple dives. This means a lot more time available underwater. Compare these examples of air and enriched air no-stop limits. The added no-stop dive time is even longer when you combine it with an enriched air compatible dive computer on a multi-level profile. And repetitive dives are longer because you have less residual nitrogen. Chances are you'll be limited by how fast you use up your cylinder, not by the no decompression limits. Enriched Air's safety record is solid. Hundreds of thousands of recreational Nitrox dives have established enriched air limits and use concepts as reliable as diving with normal air. If you make a dive breathing enriched air, you finish with less dissolved nitrogen in your body than if you had used normal air. This is a benefit, but it's too simplistic to state that enriched air is safer than air. As you'll see, higher oxygen levels create a potential hazard that hardly exists in air diving. The decompression illness, DCI, incidence rate is very low in recreational diving. Simply switching to enriched air would not be expected to change the rate significantly. Whether you have enriched air available or not, you should always apply other steps that tangibly reduce risk, such as making safety stops, maintaining a proper ascent rate, staying well within computer limits, and avoiding predisposing decompression sickness, DCS factors like dehydration, smoking, or excessive alcohol consumption. Studies show that oxygen is about as narcotic as nitrogen, so there's no meaningful difference in narcosis between an air and an enriched air dive. Plan an enriched air dive accounting for narcosis just as you would an air dive. Chances are you dive with a computer already, but if not, you definitely want to for diving with enriched air. 3 reasons. First, as mentioned, you get more no-stop dive time by combining enriched air with multi-level profiles. Second, enriched air compatible computers have alarms if you exceed your maximum depth, a beneficial secondary alert that can be very important. Third, enriched air compatible dive computers simplify dive planning by calculating both your no-stop dive time and your oxygen exposure. It's not hard to do this with tables, but your computer makes it way faster. The primary concern regarding enriched air and dive gear is the high oxygen content. Some materials readily burn or even explode when in contact with high oxygen gases, even at room temperature. Several guidelines apply to all your gear except the cylinder to address this concern. The common dive community guideline is that you can use scuba regulators, BCDs, SPGs, and alternate air sources with enriched air blends with up to 40% oxygen without modification. Above 40%, the equipment must meet oxygen service specifications, which requires special materials and cleaning. Note that local laws or standards may modify these guidelines. Follow any that apply where you are. Some manufacturers state their gear shouldn't be used with enriched air or have special requirements. Follow all these recommendations, and the use of oxygen-compatible lubricants, O-rings, and other materials is generally recommended. Have your regulator serviced as recommended by the manufacturer, preferably by a scuba technician qualified to work on enriched air equipment. If your equipment is accidentally exposed to anything other than water, such as oils or lubricants not recommended by the manufacturer, have it inspected or re-cleaned by a qualified technician. If you add any accessories, such as low-pressure hoses, follow manufacturer recommendations. Even when you can use the regulator you already have for enriched air nitrox with up to 40% oxygen, you will need a dedicated cylinder for two reasons. First, it's important that no one accidentally confuse an enriched air cylinder with a regular air cylinder. Enriched air cylinders have clear markings to prevent this. Second, one method for blending enriched air starts by putting pure oxygen in the cylinder. This is called partial pressure blending. If partial pressure blending with oxygen will be used, the cylinder must meet oxygen service standards, even when the final enriched air blend will have less than 40% oxygen. This means being cleaned and lubricated for oxygen exposure, and all O-rings, gaskets, and other valve materials must be oxygen compatible. The standard scuba cylinder doesn't meet these requirements. Enriched air cylinders filled by other blending methods may not have to meet oxygen service standards, but the cylinder must still be nitrox dedicated and marked properly. Enriched air markings identify the cylinder as containing nitrox, what the contents are, and whether you can partial pressure blend with the cylinder. These are markings broadly accepted by the international dive community. Yellow cylinders have a 10 cm 4-inch green band with yellow or white lettering reading enriched air nitrox, nitrox, or something similar. Non-yellow cylinders should have a 15 cm 6-inch band with the top and bottom a yellow 2.5 cm 1-inch band and the center 10 cm 4 inches in green. There should be a dated visual inspection sticker like on an air cylinder and another stating whether it does or does not meet oxygen service standards. It should have a content sticker or tag that shows the blend's oxygen content, the fill date, the maximum depth for the blend, and the diver's name. These get replaced or rewritten with each fill. The markings differ in some places, however, because local laws and regulations may require different additional or modified markings. For example, in Europe, enriched air cylinders have a white shoulder with a black stripe, and, generally, the entire cylinder is white. Your instructor will tell you about requirements that apply to your local area. Filling enriched air cylinders poses two concerns that you don't have filling a normal air cylinder. The first is a fire or explosion hazard. Trace lubricants and other contaminants can accumulate in standard air cylinders and pose an immediate hazard were someone to put pure oxygen in the cylinder. This is why blenders use oxygen-compatible air for partial pressure blending. Never have an enriched air cylinder filled by a station that does not handle enriched air. Enriched air should never be put into a cylinder that is not dedicated to enriched air. Another concern is the percentage of oxygen in the blend. If the percentage changes by more than 1%, your allowable depth and no decompression limits change. To manage these concerns, enriched air blenders follow strict guidelines and procedures and use special equipment not needed for regular air fills. You minimize the concerns with fills by getting enriched air only from reputable, qualified enriched air blenders. Attempting to blend enriched air without following proper filling procedures can be very hazardous. Never put pure oxygen in a standard cylinder and fill it or have it filled from a conventional scuba air fill station in an attempt to make enriched air. This practice poses a high risk of fire or explosion. If an enriched air cylinder prepared for oxygen service is accidentally filled from a conventional air source, it must be serviced and cleaned by someone qualified to service enriched air equipment before exposing it again to more than 40% oxygen. You can identify qualified enriched air blenders by looking for the following. Gas quality verification. The operation will typically display analysis results of the air it uses for enriched air blending. Proper procedures, cylinder markings, analysis, and record keeping. A lack of these may indicate that the operation isn't qualified or prepared to properly support enriched air diving. Documentation. The operation should have certification as DSAT gas blenders or other recognized blender certification from private or government bodies. Although the PADI Enriched Air Diver course qualifies you to use a range of enriched air blends, the two most commonly available are Enriched Air 32 and Enriched Air 36, sometimes called NOAA Nitrox 1 and 2, respectively. These two useful blends are frequently pre-mixed, and some places supply only Enriched Air 32 or 36. Using air within recreational limits, oxygen exposure is not really an issue, but it can be an issue when diving with enriched air. You use your enriched air compatible computer to keep your oxygen exposure within accepted limits. Oxygen exposure is measured based on the oxygen partial pressure. The oxygen partial pressure is based on the oxygen percentage and your depth. Oxygen partial pressure refers to the pressure exerted only by the oxygen you breathe. It's usually expressed in atmospheres absolute, abbreviated ATA, or in metric as absolute bar. You can use the terms interchangeably with respect to this course. Oxygen partial pressure is sometimes abbreviated PO2 or O2PP, as in PO2 0.21 ATA or PO2 0.21 bar. It's common to drop the ATA/bar reference and just say PO2 0.21. In your PADI open water diver course, you learned that an atmosphere or bar is pressure equal to the air pressure at sea level. Underwater, pressure increases 1 bar or atmosphere for each 10 meters or 33 feet we descend. The oxygen partial pressure is simply the percentage of enriched air oxygen percent, written as a decimal, times the pressure at depth in ATA bar. Don't worry, your computer does the math for you, but you need to understand what it's telling you. Suppose you dive to 10 meters 33 feet using Enriched Air 40. At 10 meters 33 feet, the pressure is 2 atmospheres or bar, 1 of air and 1 of water. 40% oxygen is written 0.40, so your computer would calculate 2 ATA bar times 0.40 equals 0.80 ATA bar PO2. Comparing the PO2s for air and Enriched Air 40 at different depths, you can see that the more oxygen in the blend, and/or the deeper you dive, the higher the partial pressure. Let's look at how you use oxygen partial pressures to stay within limits to avoid oxygen toxicity, which can be a serious hazard. Your Enriched Air dive computer tracks your oxygen exposure much as it does your exposure to nitrogen, and it's important to stay well within the limits. Oxygen exposure limits relate entirely to the oxygen partial pressure. The oxygen PO2 at 10 meters 33 feet using Enriched Air 40 is 0.80 ATA or bar. At 12 meters 40 feet using Enriched Air 36, you would have the same partial pressure. Your oxygen exposure limits would be the same for either dive, as your dive computer would show the same oxygen exposure limits. Besides oxygen exposure over time, you have to stay within the oxygen partial pressure limits regardless of time. The maximum oxygen partial pressure limit for enriched air diving is 1.4 ATA bar. You plan your dives so that you don't exceed the depth at which the blend you're using reaches 1.4, or even better, less than 1.4 to give you some margin for error. This means if your planned dive would exceed 1.4, you need to either choose an enriched air with less oxygen or plan a shallower dive, or both. The contingency oxygen partial pressure limit is 1.6 ATA bar. Dives beyond this limit have the potential for immediate oxygen toxicity. Set your computer so the maximum oxygen partial pressure it allows is 1.4. Most computers will let you do this, or are preset for this limit. Almost all models alert you if you exceed this limit. Some also display your current PO2 throughout the dive. Your instructor and/or the manufacturer literature can give you specifics about your computer. Exceeding accepted oxygen limits poses a high risk of oxygen toxicity, but it's not difficult to stay within accepted limits. If you were to accidentally exceed the contingency depth and 1.6 ATA bar for a blend, immediately ascend above the maximum depth, 1.4 ATA bar, and end the dive. Do not make a repetitive dive, and follow your dive computer's instructions. Treat the range between 1.4 and 1.6 as a margin for error only. Dive computers and tables provide oxygen exposure information for this range, but this is for emergency planning only. Divers have had oxygen toxicity while breathing oxygen partial pressures at or near 1.6 ATA bar. There are two types of oxygen toxicity that can occur by exceeding oxygen limits: CNS, central nervous system toxicity, and pulmonary toxicity. The primary hazard of exceeding the oxygen exposure limits is a fatal accident due to convulsing and drowning. CNS toxicity may cause a diver to convulse. Convulsions are not usually harmful in themselves, but underwater, the diver is almost certain to lose the regulator and drown. Therefore, it's very important to maintain good buoyancy control, navigate properly, and pay attention to factors like currents that may affect your depth. Warning signs and symptoms may precede a CNS convulsion, but usually they don't. If they do, they usually appear gradually and worsen over time. The warning signs include visual disturbances, including tunnel vision, ears ringing, nausea, twitching or muscle spasms, especially in the face, irritability, restlessness, euphoria or anxiety, dizziness. Remember vented to help you recall these. If you experience any CNS toxicity symptoms, end the dive immediately by beginning a normal ascent. There is no need for a rapid or panicked ascent, just start up immediately at a normal, safe rate. During a cavern or wreck penetration dive, ascending immediately may not be possible, but abort and ascend as soon as you can. It's best to keep your oxygen partial pressure very low or to simply use air for these kinds of dives. Other factors may predispose divers to CNS toxicity. Heavy exercise is one of these. Avoid heavy exercise if you are near or will be near oxygen exposure limits. Some drugs, including certain decongestants, are thought to predispose you to CNS toxicity. It's generally recommended that divers avoid decongestants when diving anyway. If you're taking a prescription, be sure to consult with a physician knowledgeable in diving medicine before using the drug while diving. Carbon dioxide accumulation in the body may predispose you to oxygen toxicity. To avoid retaining carbon dioxide, breathe continuously like you're supposed to. Don't hold your breath. It's quite rare for a diver who breathes normally to retain carbon dioxide. But if you frequently experience headaches after a dive, as a precaution, consult a physician familiar with diving. Keep oxygen exposure concerns and CNS toxicity in perspective. You're far more likely to approach your nitrogen limits than any oxygen limit. By setting your dive computer properly and diving well within its limits, it's easy to manage oxygen concerns. But while it's not hard to manage oxygen exposure risks, don't underestimate the consequences of failing to do so. Oxygen is an unforgiving gas, and CNS toxicity underwater on scuba is usually fatal. Because people vary in their physiology, no dive table or computer can guarantee that oxygen toxicity will not occur, even within accepted limits. So dive conservatively, well within all limits. Pulmonary oxygen toxicity results from prolonged exposure to high oxygen partial pressures. This is highly unlikely within oxygen limits while making no-stop enriched air dives. It's mainly a concern for commercial or technical divers using pure or high amounts of oxygen for long decompression stops. Nonetheless, it's a remote possibility, so be aware that the most common symptoms are irritation in the lungs, a burning sensation in the chest, coughing, and a reduced vital capacity, the size of breath you can inhale. Typically, if the diver discontinues diving before symptoms become severe, pulmonary toxicity clears up quickly and without complication given sufficient time at the surface breathing air. If you experience any symptoms, discontinue diving for a few days until the symptoms resolve, and consult a physician if symptoms are severe or prolonged. Your Enriched Air compatible dive computer helps you keep your oxygen exposure well within limits. First, as mentioned previously, set your dive computer for a maximum oxygen partial pressure of 1.4. Second, set your computer for the specific enriched air blend you're using to dive. This is how your computer knows what blend you're using so it can calculate your no-stop limits and your oxygen exposure. You'll learn more about doing this in a bit. Next, activate the scroll mode that shows your no-stop limits. Typically, your computer gives depth and times in 3-meter, 10-foot increments. With most models, the deepest depth it displays is the deepest depth you can reach without exceeding 1.4. Some models display based on 1.6. If that's true for yours, find the maximum depth using the table in the PADI Enriched Air Diver Manual. Some computers show you the maximum depth when you set the blend. Regardless, note this depth because exceeding it would take you above 1.4 and pose a serious risk of oxygen toxicity. Your Enriched Air dive computer tracks your oxygen exposure throughout the diving day much as it tracks your exposure to nitrogen. When repetitive diving, in scroll mode, many computers show your no decompression limit or your oxygen exposure limit, whichever is shorter. Most also display your oxygen exposure as a graph or other indicator in surface mode. To stay well within oxygen limits, a surface interval of an hour or more between enriched air dives is recommended when possible, especially if you exceed 50% of your allowable exposure. If your planned dives would approach or exceed oxygen exposure limits, switch to enriched air with less oxygen and/or plan shallower dives. If you accidentally exceed your computer's oxygen exposure limits, ascend immediately but slowly, make a safety stop, and end the dive. Don't dive for 24 hours or as stipulated by the computer manufacturer. Before diving with a cylinder of enriched air nitrox, you analyze it to confirm the oxygen percentage. You need to know this to set your enriched air dive computer, and you need to be sure of what it is. Even though the blender analyzes the fill, you must personally verify the oxygen analysis of the cylinder. Do not dive with a cylinder of enriched air if you have not personally verified its contents. There are no exceptions. Usually, you do the analysis, but sometimes another qualified person does it while you watch to personally verify the oxygen content on the oxygen analyzer. Decompression sickness, DCS, or drowning become very real risks if an enriched air blend differs from what you believe it is. That's why you personally confirm the analysis, verify the cylinder markings, and make sure it wasn't accidentally confused with another tank. Don't accept the analysis of another individual. It's your safety at stake, and an error will affect you. This is why the dive community standard is that it's your responsibility to know what blend you're diving by personally confirming it. Errors are rare, but they have happened. Cylinders have been confused, mismarked, or improperly refilled, and it was the diver's personal analysis that caught the error. This is why your name is on an enriched air cylinder you will use. If there's ever any question about an enriched air cylinder's contents, or whether cylinders may have been confused, reanalyze it. It's a good practice to reanalyze just before the dive in any case. In most situations, you analyze the oxygen in your enriched air cylinder yourself. Sometimes another person does it while you watch. Either way, you need to know how to use an oxygen analyzer. Popular oxygen analyzers come in different sizes and types. Whatever model you choose, for analyzing enriched air, you need one that reads to 0.1%. Different analyzers may differ somewhat in how you use them, but all generally follow the same steps. Start by turning the analyzer on and calibrating it. The simplest method is to calibrate for air. The preferred method is to flow air from a scuba cylinder slowly across the analyzer's sensor from a flow meter or restrictor. Turn the calibration knob until the analyzer reads 20.8% to 21% as specified by the manufacturer. Next, switch to your enriched air cylinder. When opening the valve on an enriched air cylinder, open the valve slowly. This reduces the heat associated with rapid pressurization, helping minimize oxygen fire concerns. Flow the enriched air into the analyzer at the same rate you used for calibration. A higher or lower rate may make your analysis inaccurate. Allow any air in the valve, lines, and flow device to clear and wait for the reading to stabilize. The standard of practice for enriched air is plus or minus 1%. Minor variations, less than 1%, between the blender's analysis and yours are normal. But confirm a substantial variation with another analyzer. Most enriched air computers use 1% increments. Round up or down to the closest whole percent. That is, for example, round 31.2% to 31% and 31.8% to 32%, unless the computer manufacturer makes a different recommendation. A few pointers will help you get an accurate analysis. Enriched air partial pressure blended in your cylinder may need 30 minutes to an hour to mix evenly before analyzing. Rolling the cylinder back and forth may speed this process. Store your analyzer in a cool, dry place and check it periodically against other analyzers, especially if you have some question about accuracy. Never blow into the sensor because moisture in your breath hurts sensor accuracy in life. Replace the sensor if it performs outside the tolerance levels specified by the manufacturer and at intervals specified by the manufacturer. After analysis, compare what you got with the percent noted on the cylinder contents tag or sticker. There are different versions of content stickers and tags, but at a minimum, they list analyzed oxygen content, the fill date, the maximum depth to which the blend can be used, and the diver's name. If your cylinder has a reusable tag, be sure that the serial number on the tag matches the serial number on the cylinder. After your dive, leave the sticker or tag in place. The blender will remove it when refilling. Some divers write empty on the sticker or tag so that the cylinder isn't mistaken for a full one. The last step is signing the enriched air fill station's fill log, which may also be a statement of understanding. At a minimum, the fill log lists the cylinder's serial number, the date, the blender's analysis, the maximum depth for the blend, and the diver's name and signature. It may record other information depending upon the needs of the operation. If you get the cylinder at the dive site, the dive operation will bring a fill log to the location. Today, the vast majority of divers use dive computers. There are 4 guidelines to apply when you're using an enriched air dive computer. First, know the enriched air blend's maximum depth and stay shallower by watching the depth display. Remember, plan your dive and dive your plan. Use the maximum depth warning as a secondary alert. Second, stay well within your computer's no-stop and oxygen exposure limits. If you begin to near a limit, ascend until your computer displays a longer limit. Stay that shallow or shallower for the rest of the dive. Third, every diver needs an individual enriched air dive computer set for the blend the diver is using. Variations in depths and blends can result in different no-stop times and oxygen exposure, so sharing isn't appropriate. As you would when diving air, stay within the limits of whichever buddy's computer gives the most conservative readings. Fourth, whether diving with air or enriched air, make safety stops and follow conservative diving practices. Let's look at setting your dive computer for your enriched air blend in more detail. How you do this varies from model to model, but with most, you enter a set mode by pressing a button or electrical contacts. Typically, you're in the set mode when the oxygen percentage blinks, indicating it's waiting for you to change it. Next, you scroll the percentage by holding a button or touching contacts, usually in 1% increments. Then lock in the desired number by holding or pressing another button or contacts. Remember to round to the closest 1% from your analysis. You'll do this before each dive during the course with your instructor at hand to help. After you've done it a couple of times, it's second nature. After a dive, most Enriched Air compatible computers clear their settings and require you to reset them before you dive again. If you forget, most go into some kind of error mode, such as defaulting to a worst-case impossible mix of 79% nitrogen, 50%, or even 100% oxygen, which causes the computer to severely limit your no-stop time, depth, and allowable oxygen exposure. It's often obvious that you forgot to set the computer, and you can surface, set it, and continue the dive. But if you don't surface immediately, after diving with a computer you forgot to set, you'll have to wait for the computer to clear, usually 12 hours, before diving with it again. The exception, by the way, is that if set for air, most models stay set for air, dive after dive, until you change it. The error mode occurs only if you had set it for something other than air and failed to set the blend for the next dive. See the manufacturer's literature for specifics about what your dive computer does if you forget to set the blend. Dive computer failures are very rare. Nonetheless, if it happens during a dive, immediately ascend, make a safety stop at 5 meters 15 feet for 3 minutes or longer, and end the dive. It's recommended that you back up your Enriched Air dive computer by writing down your Enriched Air blends, maximum depth, bottom times, and surface intervals. If your computer fails, then one option is to use tables to continue diving. Another option is wear a second, backup Enriched Air computer so you can continue diving if your primary one conks out. If you don't have any type of backup, then don't dive for at least 12 hours or longer if specified by the manufacturer before resuming with a working dive computer. Follow the accepted guidelines for diving with Enriched Air Nitrox, and it's very unlikely that you'll have to assist a diver with oxygen toxicity. However, if a diver convulses for any reason, handle the emergency as you would for any unresponsive diver underwater. If the diver has the mouthpiece in place, hold it there, but don't waste time trying to replace it if not. Immediately surface the diver, establish ample positive buoyancy for yourself and the victim, and check for breathing. Call for assistance and begin in-water rescue breaths if the victim isn't breathing. Get the diver to the boat or shore and out of the water as quickly as possible without jeopardizing your own safety. Once out of the water, check for a heartbeat and breathing and begin or continue rescue breaths and CPR as needed. Activate local emergency medical services. If the diver is breathing, begin first aid for DCI as a precaution. Even if the diver appears fully recovered, the patient should be examined by a physician. Some experts recommend that if the diver's mouthpiece is in, hold it in place and wait for the convulsion to subside, then take the diver to the surface. The concern is that a convulsing diver may not breathe regularly, but your primary concern is getting the victim to the surface to prevent drowning and to let you begin first aid and get help. Recommendations for handling an underwater convulsion may change, so stay informed and follow the current recommendations. There's no difference in how you treat a diver suspected of having decompression illness following an Enriched Air dive versus a regular air dive. Administer oxygen and first aid as necessary. Get the diver into the care of local EMS and contact the Divers Alert Network office that serves your area. When possible, tell emergency personnel the dive profile, including depth, time, and whether the diver was using a dive computer or tables, and if using Enriched Air, what the blend was. If you run out of emergency oxygen before you can get a responsive patient into emergency medical care, have the patient breathe any Enriched Air available. While not as beneficial as 100% oxygen, Enriched Air has more oxygen than regular air and may help. You can learn more about handling emergencies by completing the Emergency First Response Primary Care CPR and Secondary Care First Aid courses and the PADI Rescue Diver and Emergency Oxygen Provider courses. When you successfully finish this course, you'll have added a useful new skill to your diving repertoire. Enriched air combined with your dive computer gives you the maximum possible no-stop dive times, and that means more time doing whatever it is you love doing most underwater. Here's to your having more fun and new adventures as a PADI Enriched Air diver.